Okay, let's do the second part. So the graphs of a function and its inverse. So we'll continue with it. So the following sketch shows the graph of f of x. So there, so this one is f. And then the inverse as well is also shown there. So also the inverse, which is this one. Now, okay, with those two, what do we notice? So note the following. So take note of the following. Point number one, the graph of f and the inverse are symmetrical to each other in the line y equal to x. So they're symmetrical around this line. If you look at them. Point number two, for every point A is to B, there's a point B is to A on the inverse. So on the original, if you have A is to B, in the inverse you have B is to A. Let's look. Here's one point on the original. On the inverse, it swaps. So it's 1 is to negative 2. On the inverse, it becomes negative 2 is to 1. 3 is to 2 becomes 2 is to 3. So that's what they mean for with the second point. Third point, the x-intercept of f and the y-intercept of the inverse of f have the same value. Look at them. Let's start with the x-intercept of f. So where it touches the x-axis. So it touches the x-axis there. So they're saying this, which is the x-intercept for the original, is the same thing as the y-intercept of the inverse. So let's check the y-intercept there. So this have the same values. The x-intercept and the y-intercept have the same values. Also, for the inverse to the original, check, or basically the y-intercept is there for the original, it's minus 4. It's the same thing as the x-intercept for the inverse there. So if you check it, this is 2 is to 0, and then swaps to 0 is to 2. Here it's 0 is to negative 4, it swaps becomes negative 4 is to 0. Anyway, again, that's basically this. The y-intercepts of the original becomes the x-intercepts of the inverse. Lastly, the graph of f and the inverse and y equal to x line all intersect at the same point. So let's check them. So we have there y equal to x line, we have the original, we have the inverse. You see that they meet here, all of them. They all touch there. Okay, let's check more. So these principles apply. Use a different color. So these principles apply to the graphs of any function and its inverse. Again, the principles. It's this basically. It says it applies for any function and its inverse. Let's check example 5. Example 5 says the function f of x equals to minus 3x plus 3. 1. Determine the equation of the inverse. So this one is the one where you swap x and y, as we see, you'll see. So the original is there. You swap x and y, make y sub the formula. So you're gonna have x equals to minus 3y plus 3. So x minus 3 equals to minus 3y. You move the 3 that side, then you divide by minus 3 throughout. So you're gonna have that y is equals to minus x over 3 plus 1. So again, y equals to mx plus c. You can see your m is negative 1 over 3 in this case. Anyhow, That's how you find the inverse. Again, even if you just combine them, you still sort it. Instead of dividing individually, you can divide all both terms here. Anyway, B, sketch the graphs of f and the inverse on the same set of x's. Show the line of symmetry. The line of symmetry between the original and inverse will always be the y equals to x line. So this is always going to be y equals to the x line when you're dealing with this. So to do that, you can just find the intercepts. So if you want to sketch it, so the intercepts of the original. So let's talk about this part first. So this is the intercept of the original. That's for f. For f, the x-intercept is that, the y-intercept is that. Now let's write them as coordinates. So this is 1 is to 0. Here's when y is equal to 0. Here's when x is equal to 0. That means 0 is to 3. Now before we go to here, before we talk about this, let's sketch that for the original. So if you have those intercepts, we see 0 is to 3 will be here, and then that's sorted. Then 1 is to 0, x is 1, x is 1, there's something I'm making a mistake somewhere. X is also is this one, this first point is a mistake, it's not there. So x is 0 and y is 3, so that point is up here. That's this point, and then the second point, 1 is to 0, the x is 1, y is 0, that's there. Then you join the 2 points. So if you join those 2 points, you're going to have that graph. Now to draw for the inverse, you just swap the coordinates. This first coordinate becomes 0 is to 1. The second coordinate becomes 3 is to 0. That's for the inverse. Then you just plot those points. So close those points. So let's start with this one. X is 0, y is 1. There. Point will be, change the color. The point will be 0 is to 1. The point will be there. And then 3 is to 0. 3 is to 0 will be there. And you just join them. So you'll see if you just find the x-intercept and the y-intercept of the original, and then to draw the inverse, you just swap them. Now, if you're already given points or you're already given the original graph, you just take 2 points, swap them, and then plot them, and then you're sorted. But then back to this. So you'll see that this, if this was the x-intercept, so if you check it, if you look at this one was the y-intercept. Then it swapped, and then it became the x-intercept. So here's the x-intercept. This one was the x-intercept. It swapped and it became the y-intercept. So again, to sketch, just find the x-intercept for the original, plot those points, swap the x and the y to get the for the inverse, to plot for the inverse. After swapping them, plot them, join them in a straight line, you sort it like that. C says determine the coordinates of the point of intersection between f and the inverse, where they touch. So where they touch is here. So you just need to understand where they touch. It's where the f, y equal to x line, and the inverse meet. So you have 3 equations. So you have y equal to x, you have y equal to negative 3x plus 3. Again, let's understand what we have for C. So for C, you have f. So you have let me just put them as y. You have y equals to negative 3x plus 3. You have y equals to x. You also have y equals to the inverse, which was minus x over 3 plus 1. Minus x over 3 plus 1. Now, that's where all of them meet. So if you take two equations and equate them, any two here, they should give you that point of intersection. So the easiest one is if you take this and one of them. So take this and the original. We'll do like that. So if you take those and equate them, that is, you say this is equal to that. That is equal to that. And you solve for x. You can like get that your x that over 4. And then from there substitute into one of the equations. That means y is equal to 3 over 4. So after 3 over 4 you can put it here. You can see that y is also the same. Now you can use that if you want to. You'll see you'll still get that. After putting x here, press your calculator, you're going to get 3 over 4 again. Okay, so like it's saying here, it is usually easier to solve function and y equal to x simultaneously. So instead of taking this one and this one, instead of taking the inverse and the original, it's easier if you take the inverse, the original, or one of the equations and this one. So simultaneously then the function and inverse, that's basically what they're saying. Now remember, a function and its inverse and the line equals all intersect at the same point. That's basically what I was saying with this box. The x and the y coordinate of this point of intersection are always the same value. So as you can see here, the x and y are the same. Next question. Given the function y equals to x squared, a, determine the equation of the inverse of this function. Again, just swapping x and y. So you have the original there. So there. So you just swap x and y, apply square root on both sides. Now you have y equals to plus minus square root of x. Now we know number 2 says sketch. So sketch the graph of y equals to x squared. So we know this is a parabola. So its inverse. So sketch the graph of y equals to x squared and its inverse on the same set of x's. Show the line of symmetry. That's the y equals to x line, that dotted line. That's for B. Now, with a parabola, you know you have to have a turning point as well. So you need to have that symmetry. So with this one, you know that this one will always turn at 0 there. But then you can always use 3 points. So if you have that, you can always choose this x, basically this negative 1, 0, 1 as your x values, and then see what your y values are. So you're going to get those. Again, you can always choose this negative 1, 1, and 0. But then also, if you're given the sketch already, just take the points that are visible on the sketch, invert them, and then get the ones for the inverse. For the inverse, don't do any calculations, just invert the points you used for the original. So in this case, they have the 3 points already, and then they just invert them. And then they have points for the inverse. So with this one again, you can use the whole table of values. You can decide to choose more values instead of negative 1, 0, and 1. But then if you always choose these, they'll always work for you as well, because it'll always turn on 0 to 0 or on top of the y-axis. Basically, it's not going to move left and right. So it's safe to use these 3 points always if the inverse is involved. So let's see. So you chose those 3 points, got them. So the 3 points are, there's negative 1 and 1, 0 is to 0, and 1 is to 1. then you join them, then you get the first graph for the original. Then you can also draw the dotted line. And then to draw the inverse, you just invert the points. So if you invert the points, -1:1 becomes negative. I mean, -1:1 becomes 1:-1. So this point changes to that. Then you plot it there. Use a different color. So that point becomes here. 0:0 is still 0:0. 1:1 becomes 1:1. Then you join them. And then next one, given the function. So given the function y equals to -2x², determine the equation of the inverse. Again, A. So the original, swap x and y, make y of the formula, that is divide by -2 on both sides. First, so divided by -2 on both sides. And then this cancels that. Then you have -x/2 equals y². Apply square root on both sides, plus minus. So that's how you have that. B says sketch the y equals -2x². And its inverse on the same set of x's, not forgetting the line of symmetry, that is the y equals to x line. So let's see, again you can use -1, 0, 1 and see what you get as the y values. So for the original, you're gonna get those. So if you say use those, you're gonna get -1, -2, that's there, 0:0, and 1:-2. Those are the 3 points. Again, the x values, you just use the same as the previous one. So always use -1, 0, 1. Then you'll be sorted. That is, you plug -1 there, get the y value, plug 0, get the y value, plug 1, get the y value. So every single time you can just use those, plug them into your equation, and it'll be sorted. As you can see, we use the same ones even here. Plug those and you're sorted. C, so C says determine the coordinates of the point of intersection between the inverse and its inverse. The original its inverse. So determine the coordinates of the point of intersection between y equals -2x² and its inverse. So let's look at C. So to do that, again, the point of intersection is going to be here and here. So as you can see, all the 3 lines meet. So you see it's y equals to minus the original, basically, -2x². You have y equals to x, you have y equals to plus minus square root of -x/2. So these 2 points are the points you're looking for, and it's where all 3 meet. So if you take 2 equations, equate them, solve for x, you'll be sorted. You'll get the 2 points. So let's do that. So again, it's easier to take the original and thus, or the inverse and thus. So it's easier if you always involve the y equal to x, because it's easy to deal with. So let's see. So they took the original and y equal to x. So always take those. Take the original and the inverse. And the y equal to x line, because it's easier to solve when it's like that. When you take the original and the inverse, it becomes harder to solve. So you're gonna see this is equals to that, because they meet there as well. So there you have it. You move the x to the other side, or the 2x to the other side, whichever way you want. So in this case, they said 0 equals to x. They moved the 2x to this side, plus 2x². Then you take out the common factor, x, 1 plus 2x, and x equals to 0, or x, or 1 plus 2x equals to 1 plus 2x equals to 0, and then 1 equals to minus 2x divided by negative 2, you're gonna get the second point. So you have two of them. Now you just need to figure out which one is which one. Now remember, as long as they'll always be the same. So that means the y for this is 0 as well. The y for this is negative 1 over 2 as well. Because of where they are meeting this point, this line actually. So the y and the x will always be the same. So point of intersection, again, it's going to be 0 is to 0 from this first two, and then negative half is to negative half from the second part. And then lastly not lastly actually, there's another one for the logs. So exponential. So with exponential, again, determine the equation of the inverse, so determine the equation of the inverse of the following, and then sketch the function and its inverse on the same set of axes, sharp. So A, let's look at A. So for A, the inverse, swap x and y, you use logs. Remember, according to logs, it's going to be this is equals to is equals to log of base 2, that is base that, and then on the side there, it's going to be this one. So again, it's going to be 1, then 2, then 3. Anyhow, so you have those, and then now they said you should sketch. So let's use 3 points to draw the original. So again, you're still using that negative 1, 0, and 1. So on the original, so this, we took y equals to 2 to exponent x. On the x, we put negative 1, 0, and 1. When we found the y coordinates. Then we just need to plot those. So if you plot them, you'll see that first point is going to be negative 1 and a half there. Plot it there. 0 is to 1. Plot it there. 1 is to 2. Plot it there. Now to find, then you join them. Now to find for the inverse, you don't need to start again. You just invert what you got. So just invert the x and y. So in this case, again, invert. So for the inverse, there. Inverting means that from that. So you know, the negative 1 is to half. Now it becomes half to negative 1, and so on with the other ones. And then you plot them. So when you plot them, again, there's the first one, second one, and third one. You'll see they'll always be symmetrical around the y equals to x line, around this line. So the symmetry, you'll see, it's like the other one is a reflection of the other one, basically around that line. And then let's look at, again, B, you're going to do the same thing. Let's look at C. So for C, let it say for C, it's the log function. So the log function, again, we just still want to take 3 points. So first thing first, it is the equation of the original because they asked us to find the equation. So swap x and y, and then make y sub the formula. That is, you start with y is equals to this to exponent x. That is y equals to 3 to exponent x. There you have it. From there, for the original, well, for the inverse, I guess. So again, you can start with the original or the inverse. So here, let's start with the inverse. So the inverse is y equals to 3 to exponent x. It's easier to get it using this one. So again, you use your 3 points, your negative 1, 0, and so on. Substitute them where you see x, and then get the y values. So the y value is 1 over 3, 1 and 3. Then you plot them. So if you plot them, you'll see negative 1 is to 1 over 3 there, 0 is to 1 there, 1 is to 3 there. Then you invert the points. After inverting the points, you get those, and then you join them. Then that's it. Let me cut it here, and then I'll talk about the graph of a log function on the next video.